So for this one, the way that I go about it when I see reflect over the y-axis, I usually put my arm up in the air. I probably still do it if I'm doing questions without even thinking about it, because the y-axis is vertical. So for whatever reason, to visualize it, I put my hand up in the air and I visualize it, and then I imagine points going like this, right? They're going to flip over that. And I'm going to ask myself, if a point goes this way, is it the x or the y that changes? It's the x that changes. So as a result of thinking that way, even though it wasn't written that way, I can write that down. That it's going to be the negative with the x, just to help me see all the different points that are going to be going with, and my x values are going to change. So now when I flip it over, this point that was at 5, 2 will now be at negative 5, 2. This point right here, which was at 3, negative 2, will be at negative 3, 2. And this point at negative 1, negative 2, be at positive 1, negative 2, and negative 3, 1, positive 3, 1. And we can just connect the dots. And we have our graph. Now, we didn't need to write y equals f of negative x for that, but it's good practice when you get it in one form to practice thinking about how are the different ways that this question could have been asked, so you get comfortable with that. Now it asks for the domain and range for both of these. And then we'll look for patterns in the domain and range, because the exam sometimes likes to take away the easy parts of the question, like flipping this wasn't very hard, and then just go to the analysis part of the question, like the domain and range. And I'll explain what I mean by that after we write this down. But for our red graph, does it have a smallest x value? Yes, at negative 3. And it has a largest x value at 5. So because x is between two values, we'd go that negative 3 is less than x less than 5. In interval notation, you would just write from negative 3 to 5. The range goes from negative 2 all the way up to positive 2. And there we have both parts. Okay? Now, one of the things about writing it in this form here is with the negative there, the negative is only with the x. Only x is going to be affected. The y values are not going to be affected. So we can see from our graph when we do the range, I'll do the range first. Can you see that the range still goes from negative 2 to 2? It doesn't change, okay? The domain will change, though. Now, what happens with our x values is they get multiplied by a negative. Now, when we actually go to the graph and say, what's our smallest value? Negative 5 less than or equal x less than or equal to 3, or negative 5 to 3 this way. Okay, from the graph, it's very easy to get the domain. What the exam will sometimes do is it'll say, you don't get the graph. We just tell you the domain is negative 3 to 5. What's the domain when the line is reflected over the line x equals 0? Or when the graph is reflected? Or when it's reflected in the y-axis? And you would have to go from here to here without a graph. Couple of things you could do. The graph is super nice for you to see what's happening. You could make up your own graph and then do the flip and see what happens. And that's a very good strategy when you don't have a visual to make one for yourself and then see what happens, and then you could write the answer. Or you could see the pattern. What's happening? What this means is you are multiplying all your x values by a negative 1. You are making negative 1's positive and positive 1's negative. Can you see that that happened to our domain? What happened to negative 3? It became positive 3. What happened to 5? It became negative 5. And that order would get flipped. So just some patterns to recognize in some of these questions. Questions 3 and 13.